This video is going to cover Unit 25, Section 9, internally and externally tangent circles. Okay? Right at the middle of page 640, just slightly below middle, two circles that are tangent to the same line at the same point are tangent to each other. Okay, so we look at this situation here. We've got the big circle, and we have a tangent line to that big circle, and it's tangent right at this point right there. Now, we have a smaller circle where this same line is tangent to that circle as well at the same point. That makes these two circles tangent to each other. Now down here, we have the big circle here, and we have a tangent line to that big circle, and it's tangent at that point. That's the point of tangency. Now the smaller circle, this line is also a tangent line to that small circle, and the point of tangency is the same as the big circle. That makes this circle and this circle tangent to each other. So we can have internally tangent circles and we can have externally tangent circles. Internal and external. All right? That means that both of these circles are tangent to the same line at the same point. That makes them tangent to each other. Now, at the top of page 641, in the blue box, it says, if two circles are tangent, then a line connecting the centers of the circles, so center and center, will also go through the point of tangency and be perpendicular to the tangent line. So this line right here goes through both centers and also intersects the point of tangency to this line right here, and that makes this line perpendicular to the tangent line. The same for this situation down here. We have a line going through the two centers, and it meets up with the tangent point right there, so it is also, this line is perpendicular to this line of tangency right there. Okay? So let's take a look at how we can apply this situation to a real world problem. Okay, so right here, this is at the bottom of page 641. Zoom in just a little bit so I can get it better here. That's not bad. Okay, so we have figure 2587 right here. Is that focusing? Maybe a little further. Okay. Our goal is to find this distance from here to here, which is x. Now, we have a small circle right here. You can kind of see it arcing right there. And the bigger circle, which goes right here. This is the arc of the bigger circle. And this is the arc of the smaller circle. And they are tangent to each other. So therefore, if I have the center of the big circle here and the center of the small circle here, you can see right here, a line drawn from this center through that center will meet at that tangent point right there. So that tells me that this line right here is meeting the edge of each of these two circles. Okay? So the radius of the big circle is 25 inches. The radius of the small circle is 12. So what I'm going to do is I'm going to draw this triangle, and I'm going to draw it right here. This is x. This is what we're looking for. This is the hypotenuse, and the hypotenuse will be right here. So that will be, this is 25, and then this part of it is 12. So 25 minus 12 is 13. So the hypotenuse of that circle is 13. Okay, now we come over here. They give us this distance from here to here as 21. So find this distance, which is the same right here, we take the 21 and we subtract off the radius from this circle to this circle, or from here to here, which is 12. So 21 minus 12 is 9. Okay? Because the distance from here to here is 12, and the distance from here all the way down to here is 21. And 21 minus 12 is 9. So that distance right there is 9. That distance is 13. So I've got that triangle drawn out here. Okay? So now that I've got the triangle with the information that I need, I can pull that away for a moment. So how do I find this? Remember the Pythagorean theorem. It is, I'll just write it right out again. So it's 13 squared is equal to 9 squared plus x squared. So if we're going to find x, I drew that a little bit too close. So if we're going to find x, we subtract that. So it's 13 squared minus 9 squared is equal to x squared. So we take the square root of all of that. And the square root of 13 squared minus 81, which is 9 squared, equals, so x is equal to 9.38, which is what you will see after they work it out on the next page. I have a hard time. So they go through all of that, same stuff I talked about, and they come up with 9.38. Oh, what fun. So let's take a look at another example. Okay, on page 645, number 12 and 13 look like good examples. But on page 646, number 16, that looks like a really good example. Okay. So let me zoom this more. A little bit of a better distance. Okay, so try to recreate this on this page. So let's say I've got a center there, a center up here, and a center right there. Okay? Now, then we've got a distance from, this is the big circle right here. If you follow me along on page 646, you'll see the whole thing. I'm not going to try to draw the arcs and stuff like that because it'll just get real messy. So the radius of this big circle goes out to somewhere up in here-ish. And that distance right there is, where is that written? 75.3. All right, 75.3, the distance from here to here. Then we have the distance of this radius right here. Let's draw that arc right out to here. Now this circle comes along and it arcs out here as well. But the distance from here to here is, where is that? 26.52. Now the same thing is true over here on this side. All right? So I've got those distances. So the goal here is to find the distance L from here all the way over to here. So that distance L, that's what I'm looking for. Well, I've got this part and this part. I just need to find this center part right here. Okay? So what I'm going to do is if I take and I continue this circle around like that, and I draw this line right here, that's going to be the hypotenuse of a right triangle right here. All right, so if this distance from here to here, and this is where the two circles become tangent. You've got the smaller arc right here. I'm terrible at drawing this stuff. And the bigger arc comes along here and intersects right there. Like that. And they meet right there. So if this part of it right here is 26.52 and this whole part right here is 75.3, then the hypotenuse of that triangle is 75.3 minus 26.52, so 48.78. So 48.78, that's the distance from here to here, and that's the hypotenuse. What I'm really looking for is this one right here. Okay? So we need a little bit more information. And we have let's see, we've got a line going across. It actually goes from here across to there, and this goes over to that center. And the distance from here to here is 17.5. All right? 17.5, yep. So the distance they give us, this 65, you'll see the 65 there to the right. It's right over here, 65. So that's the distance from right here to right here. That's 65. All right? I need to find this distance right here. Then I'll have a triangle. Well, I know this part of it is 17.5. If I take, yep, I can find this distance right here by taking the 75.3, which goes all the way down to here. This is 75.3, and I subtract this part of it off, the 65, I will have this part right here. So 75 minus 65.3 would give me 10.3. Okay, so now what I have, I'll write another triangle right over here. I'll neaten this up a little bit. So this distance from here to here is going to be 27.8, and this distance right here to here is 48.78. So I'll write that as a new triangle up here just to kind of show it as neat as possible. So right here, so this side is 27.8, and this hypotenuse is 48.78. Now I want to find the distance from here to here. So I take the square root of 48.78 squared minus 7.8 squared, and I get 40, we'll take it out to 40.08. Okay, so this distance from here to here is 40.08. The distance from here to here is 40.08 times, or plus 26.52. So 40.08 plus 26.52 is 66, come on, 60, should have rounded that a little bit different. But the distance from here to here is 66.6. So the distance from here all the way over to here, which is L, is 2 times that. Times 2 is 133.2. So that's what L is. Now, okay, so all we had to do was find this triangle right here, find the sides of it. All right? The first side that I found was the hypotenuse, and I used the fact that the line, because I knew these two circles, this small circle right here and this bigger circle, were tangent. I know that. That's a given. So I know that this is the tangent point right there. So both of that line meets up with it in both places. The radius from each of these circles, the small one and the big one, meet right there. And I know that the big radius is 75.3 and the small radius is 26.52. So I can find this side by subtracting those. Now I have to look at my other information to find this side right here. So I know that the distance from here to here is 65. So in order to find this distance, I just take this and subtract that to get this distance. They gave me this one. I didn't have to calculate this. They gave me this distance. So I simply add this one and this one together to get the distance right there. And with these two sides of the right triangle, I use the Pythagorean theorem to find that one. And that is this right here. And then I add this to the radius, which comes out right to there. And I multiply that by 2 to get that.